Hi everyone, thanks for joining me here today for this session. This is SVS 207, What's New in Serverless. My name is Chris Muntz. I am currently the lead of developer advocacy for serverless here at AWS. I've been at AWS now for a little over 8.5 years across a couple of different roles, but I've been focused on the space of serverless for the last 4 years. So why are we here today? Back at the end of 2020, just a couple weeks ago, we wrapped up reInvent. So reInvent this year was a little different than in previous years. In previous years, we used to do reInvent in person in Las Vegas, and this year it has been, or I should say last year, it was a virtual event. And of course, you're seeing this session here now presented as part of the second half of that in 2021. But reInvent this year primarily took place over 3 weeks, with sessions on 3 days of each of those 3 weeks in December. So it was in this time that we announced a whole lot of stuff at AWS. It can be quite hard to keep up with the pace and the volume of everything that's coming out. I know even myself as a AWS employee spends a lot of time trying to keep on top of all of this. On top of the roughly 9 days or so here that we had back in December that we announced stuff, as you know, we're always announcing stuff. So back in November of 2020, we had what we call pre-invent. Historically, what pre-invent has been is the time before reInvent, where we have a lot of launches that we say, you know what, we're going to get this out before reInvent. It allows us to talk about those cool things and reference them in different sessions, and you can even get your hands on with that stuff before then. So between pre-event and then the official 3 weeks of reInvent for 2020, in the serverless space, we announced a whole lot of stuff. And I'm going to try to get through as much of that as I can here in this session. Now, when we're talking about serverless, I'm going to be focusing very specifically on this concept of a serverless application that is centered around AWS Lambda. For those of you that are new to this space, AWS Lambda is a compute service where you create your application code in what's called functions, Lambda functions. Today we support 6 main managed runtimes. So these are runtimes where we help with the patching and updating of those languages and release new ones periodically. So this is Node.js, Python, Go, C#, or say .NET, Ruby, and Java. I think that's one I missed there. We also have a concept called the Runtime API, which allows you to bring any language that you want to Lambda. Now, on either side of your Lambda function in this diagram here, there's basically 2 components. There is the event source. That is the thing that would invoke your Lambda function or cause your code to execute. And there's a bunch of new things that came out in the event source space. We'll talk about some of that here. And then you have what your function can talk to. In this case, databases and data stores, storage services, all sorts of things. And so we'll be focusing basically on this concept of a serverless application. Again, Lambda-centric, event sources, and then other things that your Lambda code, your business logic might need to talk to. Again, but one of the biggest challenges that we have is that we only have 30 minutes for sessions this year, versus in reInvents in the past, we could talk up to 60 minutes. So I'm basically just going to be going over briefly what some of these capabilities and new features are. I'll leave it up to you to go and find the launch content. At the end of this, though, I will have a link to a site that you can go to find all sorts of sources for launch blogs, example code, and other sessions that you should check out related to these launches. Now, I'm going to be focusing again on primarily just a couple of products where we had our biggest announcements. So that is AWS Lambda, Amazon API Gateway, AWS Step Functions, Amazon EventBridge, and then finally the AWS SAM CLI. But I'm going to leave a little bit of space at the end here for what I call the grab bag, which is a bunch of non-serverless product related features and capabilities that I think are going to be very useful for serverless developers. So with that, let's kick off. So we're going to start again with AWS Lambda. AWS Lambda has just passed its 6th birthday here for us here at AWS, which means in AWS land, it's an old service. It's used by hundreds of thousands of customers with trillions of invokes per month. It's a pretty large service used, again, by a lot of customers in a lot of different ways. Now, one of the biggest things that we announced at reInvent this year is that we were changing the building granularity from 100 milliseconds to 1 millisecond. Now, for a number of our customers that have been continuously improving their Lambda function performance, fine-tuning it very heavily, this is going to basically save them a ton of money. For customers that have sub 100 milliseconds duration functions, This could end up being a savings of sometimes 70% or more. In fact, after we announced this, I saw comments on Twitter and social media from customers saying they were saving 80 to 90%. And now where this helps again is where you have those very fast Lambda functions that execute incredibly rapidly. But for customers that bill over 100 milliseconds, you're still going to end up saving money with this again as we round to the nearest millisecond versus the nearest 100 millisecond. So awesome price change. It took effect as of December 1st. So go back and check your December bills and you should see a big change from your November bills. The next thing that we announced that's pretty exciting is larger Lambda functions. Now, what do we mean in the context of larger here? Well, what we've done is we've increased the maximum amount of memory that you can configure with your Lambda function. And if you've been using Lambda for any period of time, you know that as you increase that knob for memory, you get a proportional increase in the amount of CPU power that your function has available to it. So as you go from 128 to 256, you basically double the memory, and then of course you double the amount of CPU power that you have for your function. Now previously we used to tap out at 3 gigabytes of memory and 2 CPU cores. We've now increased that to 10 gigabytes of memory and up to 6 vCPU cores. And you can see here this chart on how as you increment the memory, you get more and more CPU up to that 6 cores. And this is going to enable customers to do a whole lot of stuff. We see customers that are doing machine learning. We see customers that are doing computational workloads, and having more memory and having more cores available to you just means you can do that much more in Invoke. And in fact, since we launched this, I've seen customers that are running functions well north of 7 gigabytes worth of memory, multi-threading inside of their function execution code, and being able to just do more with that single invocation. So really powerful thing that now gives you, or a really powerful feature I should say, that now gives you the ability to do so much more in a Lambda function than you could do previously. And again, nothing changes about how your functions were configured in the past. If you configured for 1.5 gigs, you still get the same amount of CPU as you have in the past. But again, if you need more, it's now available to you. Now, the next biggest launch that I'll talk and spend a little bit of time on here is one that we saw a ton of feedback on. And it's one that we're really excited about, as it's a pretty big shift in how you can build and deploy your Lambda functions. And this is container image support for Lambda. Now, there's a bunch of things that this means. There's also a bunch of things that this doesn't mean. Container image support for Lambda allows you now to deploy your application artifact as a container image. So whereas previously you would have had to bundle up your code into a zip file, you can now instead create a container image, put that into a container registry, in this case Amazon Elastic Container Registry, or ECR, and then tell Lambda to use that code artifact there. Why might you want to do this? There's actually a number of reasons. One is that you might have already inside your business have a well-established range of developer tools. So potentially you have container-based workloads or Docker-based workloads that you've been using in the past. You might have build tools and CI/CD tools and security tools that enable you to build those applications and work with them every day. Now you can use those same tools with Lambda and basically build your container image, test it, verify it, validate it, perform any sort of governance that you might need to do on that image, and then basically instead of shipping it to a container orchestrator, you can ship it to Lambda. Now, one of the other things this has enabled is it's given us the ability to offer application artifacts up to 10 gigabytes. So previously you would have been limited to 250 megabytes. This is a several X multiple on top of that. Why might you need that? We've seen customers asking for things like the ability to include packages such as scientific libraries, machine learning applications, and a number of other kind of big packages that might exist out there in the open source world that you might want to use for a various number of reasons. This enables you to do that, and combined with the powers of container image tools, I should say, you now can very easily build those artifacts, bundle in those larger dependencies, and ship them on forward. Now, the process for shipping a container image-based Lambda function isn't that different from how it was in the past. In this case, what you need to do first is create that image. So we support a number of different OCI and Docker formats. You can read about this in the docs to get the specifics. But once you've created your image and you've done your Docker build, or you've executed that application build somewhere inside of your CI/CD environment perhaps, you then upload that to container registry. And then from there, you point your Lambda function at it. So previously, you might have uploaded your artifact to S3. or maybe you were deploying from a local host somewhere. Again, the one step that's different here in this whole process is just going to be first uploading to Elastic Container Registry. From there, you point the Lambda function source at that container image, and then when your functions are invoked, it pulls that container image down, bootstraps the environment, and goes through the normal init process and then handler execution. Nothing else changes about how Lambda works. So this does not change the invoke path model. This does not change the event-based model. Really doesn't change anything about logging or metrics or X-ray or anything like that. All of those things work exactly the same. It's just strictly about how you function up that application artifact, and then again, the benefits that you get of doing that in this model. So it's pretty early days in this one. Again, it launched just a little over a month ago, so you may have missed it. But we'd love to get your feedback on it, see how this helps you out, and how else we can make it better. Now, another thing that I'll jump ahead on a little bit here is that we also have the support for this now in AWS SAM. So AWS SAM CLI is a tool that we have for building serverless applications at AWS. And in this case, what we try to do with SAM is make it the easiest tool for you to be able to build and deploy serverless applications. So we now have SAM support for container images, and it can take care of a lot of these middle steps of uploading the container image for you, building the container image. And so I would encourage you to check out SAM as a tool to help you do this. Now, in talking about how you might be thinking inside of your business about moving to serverless applications, migrating existing applications, one thing we always try to do at AWS is work closely with industry partners to help make this easier for you. And so as part of our container image launch, we have a number of systems integrator partners across the industry that have worked with us on this product, that have dove real deep with us on this product and understand all of the ins and outs of it. And so the companies that you see here, which you can also find on the Lambda Partners page, have this experience and are standing by ready to help you in any new applications that you might want to build serverlessly with containers as a backend, or sorry, with containers, I should say, as the packaging format. There we go. Moving on. So back in pre-event, technically actually in late-ish October of 2020, we announced another major capability from Lambda called Lambda Extensions. Now, Lambda Extensions, as the name might imply, allows you to extend capabilities of your Lambda function. What does this mean? In the past, what we've heard from companies is that they really like some of the tools that they have for things like observability, metrics, logging, security, any sort of performance-based tooling, as well as things such as, say, the ability to manage key value pairs, to manage secrets. There's a lot of different ways. Now, in the past, you might have had to include a library into your Lambda function that could call out to another service in order to interface with one of those tools. But we heard a lot from customers and we heard a lot from partners that they wanted more visibility into the Lambda environment. They wanted to understand more of what was going on inside of the execution environment, what was happening kind of before and after the function code was run and after it handled an event. And so Extensions gives you the ability to do that. And so with Extensions, you can actually plug directly into the underlying environment that your Lambda code is running inside of and do a number of things. And it works in a couple different ways, which I'm going to walk through here. The first is a concept that we have called an internal Lambda extension. Now, an internal Lambda extension runs in flight with your Lambda code. So what this means is when your function is executed upon, the extension is basically in that invoke path, can help understand or have access to what's happening inside of your function as it's running. And so there's a number of reasons, again, that you might want to do this for observability, for security. And so this is one model that exists inside of the actual Lambda function that you would run. The second model is an external extension. Now, as the name implies for this one, it runs as an external process to your function, to the execution of your function. And so it has the ability to get information from both before or after your function's actual handling of an event. And so again, number of use cases for this one around being able to handle post-event processing. So that was the first two capabilities that we announced with Extensions. Pretty quickly after that, in early November, we announced another capability, which is part of Extensions, which is called the Logs API. Again, try to make the naming for this one really clear. The logs API is an API that you can use for pointing the logs that are created by your Lambda function to different destinations. Maybe you want to take those logs and forward them directly to S3. Maybe you want to forward them to a Elastic search cluster. Maybe you want to forward them to another logging service. And so with the logs API, you can basically run an extension as an external extension that has the ability to capture that log information and process it further. You may want to pre-filter it. You might want to bundle it up and do something different with it. Whatever that might be, you now have that capability. And again, the way that Lambda logging works is that any statement that you basically just print or output would typically be captured by the underlying environment and then sent to CloudWatch logs. So it's very easy for you to create all sorts of debugging capabilities, business logic that is trying to capture certain logs or metrics, or whatever diagnostic or observability information you might have. Send that down through the logs API and then send it on to where you might want to process later on. And in this case, if you don't want to send data to CloudWatch logs instead of in place of your other solution, you basically just remove the IAM permissions from your Lambda function to write to CloudWatch logs, and then you can just capture your logs where you want to. So this could be, again, for cost savings, for performance, for further heuristics, for other things that you might want to do with your log data. Now, supporting all of this is an extension to the platform, which is essentially the Extensions API. As you know, previously with Lambda, we've had the Service API. We then added the Runtime API, which allows you to bring any language to the platform. And now we have the Extensions API, which allows you to plug into various lifecycle events that exist in and around your functions handling of an invocation and of an event. And so you see here the various levels to this, including bits that are still on the AWS line, kind of below the bar here, the purple ones. And then you see the blue sections, which are things that you can manage with your extension. So again, you have the ability to execute code as part of the extension init. So essentially when your environment is first spun up before it handles an event. You can also then execute your extensions code during that function invocation, so as an event is sent to you. And then as you'll see here, there is also this execution shutdown, which runs after the final processing of an event for your environment. And so again, what can you do with this? A whole lot of different things across observability tools, security tools, logging tools, metrics collection tools, things like environment configuration services. As an example of this, and again, talking through how we love to work with other companies to bring these tools to you, this is the list of companies that supported the extensions capability at launch. So a whole bunch of companies on here that you're probably familiar with and that you might be using already here. Organizations such as Datadog and Dynatrace and AppDynamics, companies such as Splunk and Honeycomb, HashiCorp Vault, Epsagon, to name just a few, Stackery, Symbologic, a whole bunch of people. You'll also see some AWS services on here, such as AppConfig and CloudWatch Lambda Insights. And so basically what you do is you configure your function for the extension as provided by them, and then you get the capabilities of their products. So there's no need for you to install packages or install software. You just simply enable the extension, you include the layer that it's packaged as, and away you go. Now, I will say there is one difference if you are now using the container image model, and that is that you can actually download the layer code and include it directly into your container image. And this could be as another stage or directly into your application code. It's up to you. Either way, you don't have to worry about any sort of complex installation of software packages, configuration files. Almost all of these are configured just by environment variables that are passed in through your function. So again, that's extensions, really new, big, exciting part of Lambda, and we think that there's a lot that customers are going to be able to do with this. We think there's a lot of partners that are going to be building capabilities for it, and so I would say keep an eye on this space. Now, another thing that we announced back in the pre-invent period, which is something that customers have been asking for a long time, is VPC endpoints for Lambda. Now, what VPC endpoints for Lambda allow you to do is to essentially represent the Lambda service API inside of your VPC via a VPC link, private link endpoint. And so a private link endpoint is an interface that launches, again, inside of your VPC that can connect back to an AWS service on your behalf. What this means is that your application codes can talk directly to the Lambda Service API for things like configuration and deployment, as well as for invoking Lambda functions, without having to go through a NAT gateway or a proxy or an internet gateway. So for organizations that are have very strict egress controls for their VPCs, or they just generally don't want to have to send traffic out through a NAT gateway, the VPC endpoint will basically save you from having to do that. Pretty easy to configure, and then once it's set up, it's straightforward to use. And so worthwhile taking a look at, especially if today you do have VPC workloads. And again, this is something the customer's looking for a while, so we were really excited to finally get this one out the door. Okay, another cool capability, and one that people were initially kind of surprised about, and in fact I was kind of surprised about it too when I started learning about it, is something called AVX2 support. Now AVX2 support is essentially a chipset support in newer model CPUs that gives you quite a lot of capabilities when it comes to doing advanced mathematics inside of your workloads. When might you want to do those? It could be for things such as ML workloads, machine learning workloads, for things such as image processing, for large-scale data processing, for any time that you might be doing scientific mathematic equations inside of a function. And it does require you, though, to compile your code or to have dependencies that are compiled with this flag enabled. However, you'll find that the benefits of it are really, really powerful. As an example of this, this was something that we put together for the original launch post of it. You'll see that we take an image and we apply a number of different filters to it. I, myself, am not an expert in image processing. However, I can tell you that if you look at the numbers here of before and after AVX2 support was enabled and compiled in for these application code, the drastic difference, you're talking 30+% in performance improvements in running these image processing filters. Now, if you combine this with the 1 millisecond billing, you're literally talking about saving money just by compiling your code different. AVX2 support is just automatically enabled in Lambda. There's no toggle or config that you need to do. So essentially, as soon as you compile your code for support for this, you will ideally just be saving money based on that. And so again, a lot of different factors here. This is just an example, but we have found that AVX2 support can be incredibly beneficial to a number of different use cases. Okay. And then the last one that I'll talk about here for Lambda is one that actually lives across a couple of different product spaces. And this is that during reInvent 2020, we announced the general availability of Amazon CloudWatch Lambda Insights. Now, I myself am a former operations person. I've run infrastructure both in the cloud and out of the cloud for many years. I love me some observability features. And so what's really great about CloudWatch Lambda Insights is that it helps pull together a whole bunch of information for you. Gives you really deep visibility to what's happening inside of your serverless Lambda-based applications, and gives you information from CloudWatch logs and metrics, from X-Ray, pulls in all sorts of various bits of data around things like cost and performance, and that allows you to take actions based on that. And so this becomes a dashboard that can essentially help you with fine-tuning a number of different aspects, from performance to cost to other troubleshooting of things such as the errors that you might see or other issues that might come up with your application. And so again, this is built into CloudWatch. You do have to enable X-Ray. You do have to enable Lambda Insights via the extensions for it. But then after that, you just get a wealth of information that you can use to help better your infrastructure. And so definitely would encourage you to check that out and to dive deep into the information that it provides back out to you. Okay, so that's the quick run through on Lambda. Let's jump through some of the other services that we have. Another really interesting thing that we announced right before reInvent is AWS Step Functions plus Amazon API Gateway integration. Now, what this allows you to do is to add Amazon API Gateway as an action to your Step Functions workflows. What you could do with this now is basically build, workflows that can talk to any API that you build. And so there's an incredible amount of flexibility with this. There's very tight integration between the authentication side of things as well as how it's able to do request response, or you can do wait for callback with this integration. And so customers have been looking for better ways to connect APIs that might be living either on all sorts of different backends or might be living in different infrastructure. And so this presents out to you that ability to do that. Now, a very close, I consider almost sibling feature to this is a capability that we have that is called Step Function Synchronous Express Workflows. What this is the Express Workflows, which we announced back at re:Invent 2019, which are shorter duration, faster workflows meant for very quick executions. Previously, they were just asynchronous. So you would kick off a workflow, the workflow would do its thing, but there was no basic response back to the originating side. Now with synchronous express workflows, you get back that response. So what you can do is actually build APIs that have these complicated express workflows behind the scenes that can talk to all of the services that Step Functions can integrate with, everything from Lambda to Amazon SQS, Amazon SNS, to container services, to things like batch. There's a whole number of different services that Step Functions can talk to. And if you build your workflow such that it can execute within the express workflow's duration of time, then you have the ability to have it return back up to the invoking service, the response. So this can allow for, again, really complex business logic in synchronous use cases, which is something that customers have been asking for a while. So you'll definitely want to check this one out as well. Okay, moving on to Amazon EventBridge. Back in the pre-event period of 2020, we announced a number of different capabilities for Amazon EventBridge. Two big key ones in my mind, though, however, are event replay and event archiving. Again, situations here where the names are pretty direct and to the point. With replay, you get the ability to capture events and then replay them at a future time. This can be useful for all sorts of diagnostics purposes, for troubleshooting, and for a number of use cases where you have a need to potentially take events that have come across your bus and, again, replay them at some point in the future. Auditing reasons, governance reasons, and checks and balances type workloads inside of your architectures. So a number of reasons that replay is important. Similarly, with archive, you have the ability to basically offline and essentially store events that have happened for some sort of future processing or checking. And so this can be really useful if you do need to, again, have some sort of checks and balances inside of your distributed architectures. If you do need to go back and troubleshoot maybe what might have happened during a period of time where perhaps there was something wrong with code or something didn't execute properly inside of a workflow. So two, again, straightforward features out there announced during pre-event. And then wanted to touch on AWS SAM. So AWS SAM and SAM CLI are kind of the core tools that we have here from the AWS Serverless organization to enable you to build serverless applications better, faster, easier. Now there's two components to this. There is the template side of things. SAM templates, which today are built on top of CloudFormation templates as an extension, can simplify the way that you build, deploy, and manage your applications by reducing the amount of code that you have to write in defining and, again, then going and configuring and deploying them. Now, the SAM CLI is the second part of this. The SAM CLI is a tool that can allow you to do everything from starting a new serverless project up through build, testing, deployment, and then later on the watching that function running in production. You can do things like tail logs, you can throw events at it to test it. And so it becomes a very useful tool in the lifecycle of app development. And so SAM supports functions, it supports API gateway, it supports step functions. And so there's a number of capabilities built into it today, again, that simplify your life as a serverless application developer. And so the SAM team has been working really hard to stay on top of all these new features and announcements. You can see a bunch in here related to that, such as container image support, the ability to do testing for extensions. However, they had a couple of tricks up their sleeve. So they've announced faster builds as well as parallelized builds and caching for builds, which greatly improves the speed when it comes to building your applications. And so this can be really useful for those OCI-based applications where you're pulling in large dependencies such that it doesn't have to refresh all those dependencies every time. And so definitely go and update your SAM CLI. It'll make things even better, again, without you having to change the way that you use it. Okay, that's all the main serverless announcements. I wanted to round up here with some of these grab bag announcements, as I call them. Now, these represent capabilities and features that are from across AWS and things that I think are going to be really valuable to serverless developers going forward. The first is Aurora Serverless v2. So Aurora Serverless came out a couple of years ago. It is an interesting take on the RDS service, relational database service, Aurora. And with Aurora Serverless v2, they've made a number of improvements to how it scales, to how it handles failure, to things like read replicas. And so you can expect that to be rolling out more here in 2021. But I'd keep your eyes on this space. I think it's really going to change how serverless developers build for relational database types. The next I'll talk about is Amazon DevOps Guru. This is a really cool service. Again, I am a former operations or DevOps person myself. What I like about Amazon DevOps Guru is that it takes some of the best knowledge that we have inside of AWS. It takes some of the experience and learnings that we have for decades of running some of the world's largest infrastructure and from supporting customers running some of the world's largest infrastructure. And it allows you to apply machine learning techniques on top of your existing applications. It can identify all sorts of potential faults, gaps in things like monitoring, places where you can fine-tune things better. And it does this just by basically looking at what you configure for an application and how it's configured. So pretty smart stuff, really pretty interesting. I would definitely encourage you to turn that on and take a look and see what it reports back to you. Next, in a similar vein, is Amazon Lookout for Metrics. Now, Amazon Lookout for Metrics is another machine learning service that basically looks for outliers, interesting changes, stuff that doesn't seem typical or normal in metrics that you provide to it. You can grab those metrics from a number of locations, whether it be CloudWatch or other AWS services. And again, this could be metrics for AWS services or custom metrics that you capture. And then lastly, we have AWS Proton. So AWS Proton is a new service that allows you to deploy and build applications both for serverless architectures and for container-based offerings. With AWS Proton, you get the ability to control both how the pipelines for deploying those applications are built and then how those applications themselves are later on built. So it's a bit of governance, it's a bit of auditing, it's a bit of guardrails, I should say, as well on top of that. Okay, we've covered a whole bunch of stuff here today. Again, this was a quick run through of all of the exciting things from reInvent 2020 focused in the space of serverless. Again, the big takeaways you want to come through with this is that serverless becomes even more powerful. Every year here for the last couple of years, we've announced capabilities that make serverless services more robust, they give you more flexibility, and ideally with you doing less, right? So less operations work, less undifferentiating heavy lifting, less managing of servers, more benefit to your business. You can check the link here again for all of the links about these launches, other talks you want to check out. Whether you look at the short code here for serverless land or this QR code, it'll take you to the same place. And again, I want to thank you for coming. My name is Chris Munz. I lead developer advocacy for serverless at AWS. You can find me at munz@amazon.com or at Chris Munz on Twitter. Hope you enjoyed reInvent this year. Hope you're enjoying the extra time here in reInvent and hope to see you in a future event. Thank you.